Hello everyone, my name is Fitzum. Today I'll show you how to calibrate and validate SWAT simulation output in SWAT CUP software. So in order to do that, first we have to install the SWAT CUP software in our computer. So as you see from here, this is the SWAT CUP software file. You can get it from internet freely. So open the folder, then you'll get the setup. Right click and run it as administrator. Then click yes, then wait for some minutes. Then you'll get this window, SWAT CUP 2012 setup. Click next, then next. Then wait for some minutes again. It is installing. So the installation process is over. Click finish. Now it is opening. So this is the SWAT CUP software. So in order to start a new project, go to start and left click and create a new project. Then click next. Then browse the SWAT output. So my SWAT output is in desktop. I'll go to desktop, sim2, then browse or import text in out file. Select this text in out and click open, then click next. Then your my SWAT version is 2012. Processor is 64-bit. Then click next. Then select project type. Let me select Sophie2. Then click next. Let me give it project name, SWAT, and let me give project location. Let me give desktop again. Then click finish. Now it is copying the items from the SWAT output folder to desktop to our project. So we have to wait for some minutes. So here in Project Explorer, you'll see calibration inputs. Expand that. Open para inf. Then here we have number of parameters and the number of simulations. So as you see from here, we have only 4 parameters and number of simulation is 500. Let me make it 5 only because it is only for tutorial purpose. But if you want to add a new parameter, you can add here. You can add by clicking this one, add a new parameter. So there are several parameters here, so you can add any parameters which are suitable with your variable. When we say variable, it may be runoff or statement. So for now we have only 4 parameters. Let me leave the default parameters, then open the second. We have starting simulation 1 and the ending simulation 5. Then the third one, we don't need to edit anything here, but keep in mind number of years simulated, which is 8 years, and the beginning year of simulation 2001. Then absolute SWAT. Even here we don't need to touch anything. Go to observation. Then as you see from here, in observation the things are not activated. So in order to activate these things, come here and check reach. Then double click on observer reach. Then number of observer variable is, in my case it is 1, only runoff. Then here we need observer discharge, but before copy pasting the observer discharge here, we have to prepare observer discharge in this format. So I have a YouTube video how to prepare SWAT observer discharge, so you can refer that video. Then after preparing this format, copy this one, copy, and then select this one, select the first, and then click shift and select the last. You can select all, then delete, then paste the observer discharge, and click this one, the number of observation, then paste it here. Then go to extraction. Our flow out is only 1. Then SUFI2, number of variable is only runoff. In the SWAT output, you will get the simulated discharge in column number 7. That's why I put 7 here. Number of total number of freeze or sub-agent, in my case it is 5. Number of freeze sub-agent to get the first variable, I'll get my variable in sub-agent 1. This one is also 1. And number of freeze for second variable, I don't have second variable, so I will delete this one. Then beginning year of simulation not including the warm-up period, I have 2 warm-up period, so I will add, as you see from here, beginning year of simulation is 2001, but my warm-up period is 2, so I'll add 2001 plus 2 years, it will be 2003, and the end period of simulation is 2008. Our number of years simulated is 8 years, so that's why I wrote 2008 here. So time step, we have daily, monthly, yearly, so I'll go for daily 1. Then expand objective function, number of variable 1, objective function, let me go for R square, which is 3. Mean value of objective function, threshold for behavioral solution, let me leave the default, this one also default. Then select the first, then click shift, hold shift, and select the last, then delete, then copy this file again, the observer discharge, paste it here, copy this one, or number of observation, paste it here, then var, we have only 1 flow out, no observation, number of variable 1, we'll get the simulated discharge in column number 4 and 7. We have only, we are going to calibrate and validate only flow, so delete the remaining. Number of sub-agent is 5. I'll get the discharge from sub-agent 1. Then for the second and third, we don't have second and third variable, so we we'll delete this one. Beginning year of simulation without the warm-up period, it is 2003, 2008. Then time step 1. Repeat the same thing here. Number of variable is 1, 7. Here copy this one. We don't have this variables, only flow. Sorry. Number of subdivision are 5. We'll get the discharge from subdivision 1. We don't have second variable, third variable, and fourth variable, so delete this one. This is 2003, 2008, which is the same with the previous one. Then this one, total number of subdivision is 5. Total number of HRU 78. I will get the discharge from HRU 1. I don't have second variable, third variable, so I'll delete this one. Then 2003, 2008, time step 1. I have already edited. Discharge is 4. 1. Number of variable is 1. We'll get our simulated discharge in SWAT output in column 7. We have only flow, number of subdivision, so we have already edited this one. So go to the forge. We don't need to edit anything. The last one is this one. So number of variables is 1. So we don't have this variable. Replace it with the flow. Then number of observation are 1826. Sorry. So let me check it. Our number of parameters are 4. Number of simulation are 5. We don't need to edit anything. The same here. Var. Delete this one. Number of variable 1, column 7, total number of reach 7, number of reach 1, 2003, 2008, 1. Observed 1, number of observed variables. Our objective function is 3. Threshold is 0.5. Then var only flow out 1. Number of variable 1, column 7, only R flow. Total number of subdivision 5, 1, 2003, 8, 1, 7, 5, 78, 1. So I'm checking the errors if I made any mistake. 1. So we don't need to do anything here. The last one. So everything is good. So come here and save all. Then after doing that, come here and click on Calibrate and execute all. Then you will have yes or no option. Click Y and enter. Process finish. Close the window. Okay. Start the execution of SWAT 2. Click OK. Now it is executing. It is executing simulation number 2, simulation number 3, simulation number 4, simulation number 5. So as you see from here, the SWAT is not recognized as internal and external command, so we are not successful. So mostly you may face this kind of problem. So I'll show you how to fix this kind of problems. So here I have listed the two mostly commonly happens errors in SWAT-CUP. SWAT is not recognized as internal or external command, so the same error. So how can you fix this kind of error? Go to the folder where you have installed your ArcSWAT. In my case, I have installed my ArcSWAT in local disk C. SWAT, ArcSWAT. Then find a file with the name of SWAT 2012, which is executable file. This is the file, SWAT 2012. Copy this file. Copy this file and paste it in SWAT project. I don't need this one anymore. I'll close it. So go to SWAT project and paste it here. Then rename it SWAT extension. SWAT extension. So now you can fix the problem. So go back to the SWAT-CUP and save and click Calibrate again. Execute all. Write Y and enter. Okay. Okay. Now it is executing. So after doing this correction, you are not going to face the same problem. So as you see from here, it is executing the simulation number 1 successfully. Now it is executing year 1, executing year 2. So from this, it is obvious that we are not going to face the previous problem. And the other thing I want to tell you is sometimes in addition to this error, you may face this kind of error. Number of years of simulation do not match. So in order to fix this problem, in my case, number of years simulated is 8 years. This means it is from 2001 to 2008. Keep in mind this. Beginning year of simulation is 2001. But we have two beginning year of simulation, not including the warm-up period. So if you escaped 2 years, so you have to add 2 years on this one. 2001 plus 2, you'll get the beginning year of simulation, not including the warm-up period, which will be 2003. If you escaped 1, it will be 2002. In my case, I escaped 2 years, so it will be 2003. Then in the year of simulation is, as I have told you, the number of year of simulated is 2000. It is 8 years. So if you add 8 years in 2001, you will get 2008. You can count from 2001 to 2008. It will be 8 years. So that's why I put it 2008. So if you do this, you are not going to face or encounter this kind of error. But if you faced this kind of error, a SWAT not recognized as internal or external command, go to your ArcSWAT folder, then copy this kind of file with this name, SWAT 2012, copy it and paste it in your project, then rename it SWAT extension, so you can correct the error. So now it is executing here, it is executing the last simulation. So as you see from it, the execution is successfully completed. Click OK. OK. So as you see from it, our execution is correct. So process is finished. OK. Do you want to save the iteration? Yes. Let me save the iteration. iter1. Then expand this iteration. Then expand calibration inputs. Then check the summary. As you see from here, my objective function is R scale. So as you see from here, my R scale is too low. Then you can check all the calibration outputs. This is the graph. This is .t plots. This is best parameter. This is best simulation. This is the goal. This is the new parameter. So let me back to summary. As you see from here, this is my objective function, but as I've told you before, the objective function is too low, so I have to go for next iteration. Go to para, then here you have to add additional parameters, and you have to check the ranges also. Minimum and the maximum, you have the range here, so you have to check the ranges are correct or not. So after doing all this, if you want to add any parameters, go here and add new parameters. If it is runoff, you have to add the parameters which are suitable to model the runoff, and if it is sediment, you have to add the parameters which are suitable to model the sediment. So after adding and after arranging the range, then go for the second iteration. But before doing that, go to here and you can import new parameters. Here you are about to import new parameters and replace them with the existing parameters. Are you sure you want to do this? Yes. Parameters have been imported successfully. Okay. Then close this one. Then go for second iteration. Come here, calibrate, execute all, Y, enter. Okay. Okay. So now we are doing the second iteration. So after checking your objective function, if your objective function is not good, you have to go for second iteration. Then do the second iteration. If it is the objective function is not good, go for third iteration. Check your objective function. If it is not good, go for the fourth iteration. So until your objective function is good, you have to go for the further iteration, but mostly only 4 iteration is recommended. So you don't need to go for the 5th or 6th. So after doing the first iteration, check your parameters, whether your parameters are correct or not. Check your range of the parameters. If the range of parameters are not good, you are not going to get good objective function. So before going to the second iteration, you have to check everything. You have to check your parameters, you have to check the range, you have to check your observer discharge. So you may face low objective function because of several reasons, so you have to fix all those reasons. If it is because of the parameters, you have to fix the parameters. If it is because of the range, you have to fix the range. If it is because of the observer discharge, for example, you may have mistake on your observer discharge, so you have to check everything in order to have good objective function. After doing all this, go for the second iteration. If it is not good, check your mistakes, then go for the third iteration. So finally you will get the good objective function. Then end your process of the calibration. Then after calibrating, go for the validation. If your validation objective function is good, so you have successfully validated your SWAT output. So you can go for the next step. So our second iteration is good. Click OK. Okay. Now we are doing the second iteration. Okay. Do you want to save iteration? This is the second iteration. go to second iteration, check summary. So as you see from here, my R square is improving, but it is too low. This is because of the parameters. I have only 4 parameters, so I have to add parameters. I have to fix the range. So after doing that, I'll go for the third iteration. But before going to the third iteration, I have to correct all the problems. I have to add new parameters. I have to add additional parameters. I have to check the range. How can you check the range and how can you add new parameters? You have to refer a papers which were done in your area. For example, if you are doing in some area, refer or do a literature review, then you'll get the parameters, you'll get the range. So use that parameters in that range. If the research are not done in your area, go for the, for example, in my case, I'm in Ethiopia, so I'll go in, for example, if I'm in East Ethiopia, I'll find, or I'll try to find a papers which are done in East Ethiopia. So if I got that, I'll refer the parameters and read the range from those papers. But if there are no papers in East Ethiopia, I'll go for the whole Ethiopia. Then I'll go for Africa. Then I'll go for the wallet. So you have to refer in this way. First, you have to go for your small area. Then if you are not going to get a paper in that small area, you are going to go to the next area. So you can refer a papers in order to get the parameters and the range. Then after doing that, for sure you will get the new objective and you will get good objective function. So you can do calibration and validation by doing this step. Thank you for listening. If you like this video, please subscribe my channel. Thank you. Bye.